Here's a parallelogram ABCD, where BA needs to prove line segment AM is congruent to line segment CM. She has an outline of a proof. Help her add in the reason for each step to turn her outline into a complete proof. So I'm just going to highlight the line segments that Rabia wants to prove that are congruent. So line segment AM is right here, and line segment CM is right here. Now we already know that in a parallelogram, diagonals bisect each other, which already immediately shows us that these two line segments are congruent. But let's just say that we don't know that the diagonals in a parallelogram bisect each other, and since that is something she's trying to prove, we cannot actually use that property of a parallelogram in this scenario. What we're going to do instead is prove that triangle AMB is going to be congruent to triangle CMD. And then after we prove that these two triangles are congruent, then we can say, well, all the corresponding parts of these congruent triangles are also congruent. So first, we're going to look at our statement. We want to write everything that's given to us. The only thing given in this example is that we have parallelogram ABCD. So we're going to write given for number one's reason. And then number two, we can say that line segment CD, right here, I'm going to add that tick mark, is congruent to line segment AB. And we know that because in a parallelogram, opposite sides are congruent. And I'm going to write this congruent symbol here. Now we can say for number three, the angle MCD, so MCD is this angle right here, is congruent to angle MAB. MAB is right here. And the reason for this is because parallel lines cut by a transversal form congruent alternate interior angles. And we know that we have parallel lines because we're dealing with a parallelogram, and the word parallel is in parallelogram. Then we know that angle ABM is congruent to angle CDM. So ABM, that angle is right here. And I know it's congruent to angle CDM, which is right here, because of the same reason. In a parallelogram, parallel lines cut by a transversal form congruent alternate interior angles. So I'm going to write the same reason here, parallel lines. And on the regions, if you don't want to write out everything, you can just write quotation marks to mean that's the same thing as above. So parallel lines cut by a transversal form, and I'll write this out, congruent alternate interior angles. Same reason. Now we can say that the two triangles are congruent by angle, side, angle, triangle congruence theorem. Because we have an angle here, we have a side length here, and an angle here. Same thing as above. We have an angle, a side in between, and another angle. And now we can say line segment AM is congruent to line segment CM, because corresponding parts of congruent triangles are congruent. Again, once we prove that both triangles are congruent, all of the corresponding parts now become congruent.